Hello, this is Dr. Oz. I would like to talk about product mix problem today. So let's create a new Excel file. I will name this Excel file as product mix problem. All right. So here in this kind of problem, this is part of a linear programming, a very common optimization problem. And basically we are trying to figure out how many products should I produce. And imagine you can be a manufacturer or service company that produces products or goods or services. And then each of these goods and services utilize certain amount of certain processes or inputs. So we are trying to maximize our objective, which is profit, and without violating certain constraints. So let's get started. All right. So I would like to start with the given information. Right. Given information, I will put my information that's given to me. I have certain processes, and also I have products. So for this example, I have three different types of products, but I could have more products, of course. The first one is stools. I have office desks. And I have dining tables. All right. These are my three different types of products. And I have three different processes. One, electronic department. Machinery. You can call it more machinery. Let's call it machinery or electronic. Hours, machinery or electronic hours. I need 8 hours here, 12 hours here, and 4 hours here. I have assembly hours. Okay, let's say these are 6, 12, and 8 hours. And also I have another process called packaging hours. And here I have 4, 4, 6 hours. These numbers could change, obviously, but this means, for example, to be able to produce a dining table, I need 4 hours of electronic or machinery hours, 8 hours of assembly, and 6 hours of packaging to be able to produce one dining table. And each of these processes have certain capacities in terms of hours. So electronic department or process, excuse me, has 2100 hours available. Packaging has 2500 hours and 1700 hours for packaging, so 2500 hours for assembly. And also I have demand for each of these products. For stools, let's say I have demand of 360 units in market, for 24 office desks, and 300 for design tables. So these are my demands. And I have profit given for me per unit. I have profit of $30 per unit for stools, $70 per unit of office desk, and $52 per unit of dining tables. Right. Dollars. Okay, perfect. So now I also have a constraint in this problem as minimum number of stools, because I need to sell so many stools. I have a contract with my customer. At least I need to sell 250 stools this month. All right, so let's look at the model section. Build our model. As you know, I like to ask myself the first question is, what's my objective in this problem? The first component of the optimization model, as we know, we have three components: objective, decision variables, and constraints. Objective is, in this problem, the objective is maximize the profit. Why maximize the profit? Because I have profit margins given to me. There is no cost information, it's just the profit margins. And I will calculate my profit right here. And I like to color my objective as green, so I will calculate it here. Second component is the decision variables. In this case, I have three different types of decision variables. These are associated with number to produce. So I need to decide how many of each product do I need to produce. I have stools, office desks, and dining tables. And I will highlight these ones yellow because I don't know their values, and these are my decision variables. All right. So now I would like to introduce the last component of an optimization model, which is constraints. And in this case, I have several constraints. One constraint is number of stool to produce. So what I'm gonna do is I will put their names here. Maybe I can just number them. 3.1 stool produced. So I have again left-hand side value, which I need to calculate these values. I have relationships, this constraint relationships, and then I have right-hand side values, which should be given to me, right? So still produced, I currently produce nothing, but I need to reference the decision variable. This will have a value. And I would like to make sure that I will produce more than 250. Okay, this is my first constraint. Let's look at the second constraint that I have, which is electronic hours used. All right, so electronic hours used, currently I'm not using anything because my decision variables are still have no values. So these are my decision variables. I need to multiply their corresponding electronic hours coefficients right here. Okay, and I want to make sure that this is less than or equal to my capacity in terms of electronic hours, which is 2100. Right? Let's continue to the next constraint, which is assembly hours. And again, I will use some product function to multiply decision variables with their corresponding coefficients. For the left-hand side, I want to make sure that this value is less than or equal to the capacity. All right. So let's talk about the next constraint, which is packaging hours used. Again, I will use the same sum product trick to multiply decision variables values, but their corresponding coefficients. And I want to make sure this value is less than or equal to their right-hand side capacity, which is 1700. Okay. All right, so I'm done with these capacity constraints. and also the contractual constraint. Now what I'm gonna do is I would like to look at my capacity constraints, sorry, demand constraints. So I have three demand constraints here. So I will put them here. First demand constraint is stools demanded. And currently I produce 0 stools. I want to make sure that that is gonna be less than or equal to, I produce less than or equal to the demand, because I cannot sell really more than 360 units because that's the maximum demand that I have out there. I have very similarly office desks demanded. Right? And here, very similarly, currently I produce no office desk. I want to make sure that my production amount is less than or equal to the demand, which is 420. Finally, I have another demand constraint here, which is dining tables. All right, dining tables demanded. Currently, I produce 0 dining tables, and I want to make sure that that value is less than or equal to the demand for dining table, which is 300. All right, so I'm all done with constraints. These are my constraints. I can just color them something reddish color. This red. All right, so these are my decision variables. Again, those values are going to be calculated by Excel solver. These are the rules or constraints that regulate my decision variables values. Finally, I need to calculate my objective. Again, maximize product profit. I will use some product track again. My decision variables times their corresponding profit margins, right? Currently, I make no profit, but if I start producing products, I will start making money. All right, so let's build our model. Again, if you don't have Solver, Excel Solver, please click on File, Options, and then Add-ins. Under Add-ins, you will see Analysis Toolpack. Click Go, and then make sure that the Solver add-in is checked here, and then click OK. Once you've done this, basically what you are gonna do is go to Data, Solver. Now I define my objective, which is my green cell right here. The maximization problem, I'm maximizing the profit. My decision variables are these yellow cells. I can add my constraints. Let's add my first constraint. I want to make sure that I produce more than or equal to 250 stools. And then I can add these constraints all together because they have the same relationships. I want to make sure that these values based on decision variables should be less than or equal to their corresponding right-hand side values. I click OK. I have all these constraints. Make sure this is checked. And then this is a linear programming problem, and then click Solve. Once you did this, you will get the optimum solution. Again, the optimal solution is this company make $8,800 profit in this month by producing 250 stools, 0 office desks, and 25 dining tables. And if you look at all the constraints, you're expected to produce 250 stools, and we are producing 250. We are expected to have capacities 2,100, 2,500, and 1,700 in each department, and we are using less than or equal to those capacities, and demands are 364, 2,300, and you see there is no violation here either. So next video, I would like to talk about sensitivity analysis. All you have to do is just click on sensitivity and click OK. That will create your sensitivity report. You have a great day. I hope you enjoy supply chain management.